going to take a look here at the index of refraction, meaning how light bends based on what materials it's traveling through. So up here at the top I have a semicircle that's a piece of glass, and what we're going to do is we're going to shine our light at different angles here, starting at 20 and going to 50, and we're going to see what happens as the light passes through the air, and then hits the glass and then bends at a different angle. So we're going to start off by taking our ray box and shining it down the 20-degree line. Each of these small lines here is worth 10 degrees. Next step is to draw the refracted ray, the ray that's coming out of the piece of glass. After that, we're going to measure what the angle is. But first, we're going to draw all 4 of our rays, and then we'll be able to move the light box out of the way. Okay, so now that I've measured the 4 refracted rays, we can really easily see that the rays come in and then leave at a different angle. And all the angles are smaller as they pass through the glass. This is for a couple of reasons. The first reason is that glass is denser than air. And what that means is that the speed of light is going to slow as it passes through the glass. That's going to cause it to bend. What that's going to lead us to finding out is that the index of refraction of glass, which is a property of the material, is going to be greater than air. Air we're going to call as having an index of refraction of 1, and then pretty much every other material is going to have an index of refraction greater than 1 if it is denser than air. Let's take this data now and summarize it into a chart. Now that we have all of our data in a table, we can start to analyze it a little bit better. So in the first 2 columns, I have the angles of incidence and the angles of refraction, so before and after the light passed through the glass. In the third and fourth columns, what I have are the signs of those respective angles. So this right here is the sine of 20, 0.225 is the sine of 13, so on and so forth. In the last column, what I'm going to do is I'm going to actually end up calculating the index of refraction of the glass. So we have this equation here, n equals sine theta I, so sine of the angle of incidence divided by sine theta r, so sine of the angle of refraction. If we divide these 2 numbers, so we're going to divide the number in column 3 by the number in column 4, we can get a number usually close to 1, but bigger than 1, showing us that it's more dense than air. And we get 1.52, 0.53, 0.58, and 0.53. So all of our numbers are pretty consistent. If I took all of those and averaged them out, I would get 1.54, and that's very close to the index of refraction of glass, which is between 1.52 and 1.53. So in summary, that's just a quick lab showing you how light bends as it passes through different media. And it's also showing us that as the medium gets denser, the index of refraction increases, so it's greater than 1, which is what is shown here, and the angles decrease.
Thanks for watching. Make sure you like, get subscribed, leave a comment below, and check out our suggested videos. Make sure you hit the bell icon so you don't miss any future updates.